We continue discussing probability distributions, and in lecture 7 we will focus on sampling distributions. This is a very quick overview, so I will start with an introduction where I will introduce some terms that you need to be familiar with. After this, I will move to sampling distribution to give you an idea what a sampling distribution is. After this, I will discuss the properties of sampling distribution, and in section 4 and 5, I will discuss two types of sampling distribution: the sampling distribution of mean and the sampling distribution of proportion. So let's move to the introduction. There are two terms that you need to familiarize yourself with, is parameters and sample statistic. So parameter, this is some descriptive measure that is used to describe a population. And because it is based on the values from the population, most of the time we do not know the value of this descriptive measure. And population measures are denoted in the following way. So mu is used for population mean, sigma squared is used for population variance, sigma is used for population standard deviation, and p will be used for population proportion. I will also call it probability. And since we already know that we almost never deal with population, but rather with samples taken out of a population, and to describe this sample, we use sample statistics, and it is calculated from the observations in the sample. And here you can see the ways those descriptive measures are denoted. So x with the bar, this is sample mean, s squared, this is sample variance, s, this is sample standard deviation, and p with the hat, this will be sample proportion or probability. So here on this slide, you can see a quick summary. So in the first column, we've got the numeric descriptive measures, mean, variance, standard deviation, proportion. So in the next column, we've got the corresponding population parameters, and in the last column, sample statistics. What you also need to remember is that, for example, x with the bar, so sample statistic, is the so-called point estimator of population mean. So therefore, s squared will be just point estimator of population variance, s will be just a point estimator of standard deviation, of population standard deviation, and p with the hat will be nothing else but just the point estimator of proportion.